Today we're going to be talking about tangents. And two circles are externally tangent when the two centers are outside of each other, but they are tangent, which means that they have one intersection point. Okay, so they're externally tangent. Now we're internally tangent when one circle is essentially inside of the other and they intersect at one point. A common tangent is a line that intersects two circles. Now there's two different types. Circles on the left, A and B, have a common external tangent, which means that L and M are both externally tangent, that when they cross through, they wouldn't cross through the line that passes through the center of the two circles. Versus P and Q are common internal tangents. When I draw a line through AB, those lines, P and Q, are going to intersect that line that joins the two centers of our two circles. If a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. Meaning if I have a circle here and O is our center, and I draw a line that's from the radius essentially to our tangent, we're perpendicular. And then if a line in a plane of a circle is perpendicular to the radius, then the line is tangent. So if you think about it, this is essentially the converse of what we had. So if I have a perpendicular, then we know that this line here is tangent to our circle. And this has to be a radius. OA has to be a radius. And this next one is the one we're going to be using a lot. We're going to be using those other ones a lot too. So tangents to a circle from a point are congruent. So if you think about it, we have circle, I'm going to give it a name, I'm going to give it circle O. Tangents to a circle from a point are congruent. So I have a point out here, Y, and I have two tangents, XY and XW. Those are going to be congruent. Now think about why that could be. When I draw my two radii, think about what we just said. We're going to have a right angle. When I draw in line OY, let's look at why these two triangles, OYW and OXY, would be congruent. We know all radii of a circle are congruent, so those are going to be congruent. We also know OY is congruent to itself. And OXY and OWY are going to be right triangles. So triangle OXY is congruent to triangle OWY. By what reason? We have hypotenuse, leg, by our hypotenuse, leg theorem. Okay, our first example. We have AB being tangent to circle C at point B and AD tangent to circle C at point D. Find the value of x. Well, we know tangents to a point are congruent. So that AD is congruent to AB. So therefore, x squared plus 24 is equal to 49. I subtract 24 from both sides to get 25. Now remember, what undoes a square? A square root. Every time I square root, though, I need to remember that it's plus or minus 5. Because if you think about it, if you plug in negative 5 here, when I plug in negative 5, I square it, that's going to be a positive 25. 25 plus 24 is equal to 49. In this example, we have circles P and Q, have radii 6 and 12, are tangent to each other, and the length of their common external tangent AB. So I'm looking for the length of AB. So let's think about what we know here. We know PA is equal to 6, QB is equal to 2, and they are tangent, so that length is going to be 2 plus 6, because each of those lengths are radii, so that is equal to 8. There's a trick that we're going to be using a lot in this chapter with this. We know that that we are perpendicular. PA is perpendicular to AB, and QB is perpendicular to AB. If I were to draw a segment, I'm going to call it QX, so that we are perpendicular to AB. Then I'm going to have a rectangle. ABQX is a rectangle. So therefore, since opposite sides of a rectangle are equal, I know AX is 2, making PX 4. Now we have a right triangle in here. So if I find QX, that's going to help me find AB. So let's write out an equation to find QX. Well, that's our Pythagorean theorem. So PX squared plus XQ squared is going to equal PQ squared. PX is equal to 4. QX is what I'm looking for. And PQ is equal to 6 plus 2, which is 8. So I really have here 16 plus XQ squared equals 64. So XQ squared is equal to 48. XQ is equal to the square root of 48. I don't worry about the plus and minus since we're talking about a length. And then I have to simplify that radical, so that's going to be 4 root 3. So XQ is equal to 4 root 3. Our last example. We have to find the radius of the circle inscribed in the triangle. And the radius, obviously, is the center tangent. So I have a right angle there. That's going to be my radius. Now we also are up tangent right there, where that's also a radius. And what we have is we're going to have two similar triangles. When you draw down your altitude of your isosceles triangle, that's also going to incorporate part of your radius. So we're going to have, and we know that when I drop my altitude down, that we intersect at the midpoint. So this piece is 3. So we have one right triangle where we have that is 3. And let me highlight it in red for you guys. This piece is 16. I do my Pythagorean theorem to get root 247. Now we have another right triangle that is somewhat challenging for guys to see, but it's one that we're going to be using a lot throughout multiple chapters. We have this triangle right here, where my right angle is right here. So I'm going to redraw that triangle. I have my right angles equal, and then this top angle is equal to itself. So that's that angle up there in both of those triangles. That means this bottom leg is equal to R. Now I need to find this other leg, or this segment right in here. Now let's look at this bottom piece right here. we know that tangents to a point are equal. So this is equal to that right there, making that 3, making this other leg equal to 13. So now all it is a matter of setting up proportions. 3 is to r as square root of 247 is to 13. Now cross multiply. I solve for r. Now I have to rationalize my denominator, so I multiply the top and bottom by the square root of 247. That leaves me with just regular 247 on the bottom. Now, using your calculators and looking at common multiples, 13 goes into 39 and 13 goes into 37. So that's going to simplify to 3 square root of 247 all over 19. Now these are some crazy numbers, but that's just because of the numbers that I picked for the 6 and the 16 and the 16. You're going to have a lot easier of numbers when you do the problem in your classwork. Okay, there are your lesson questions. Please make sure that is submitted on time.